Greetings and welcome, friends. Today we're moving beyond the arithmetic and into the geometric. That's right, this is probably pronounced the way you would have imagined. Geometric sequences and series, to be exact. And to start, let's talk about what I mean by a geometric sequence, because it's not a pattern with shapes in it, right? So, a sequence in which each term is found by multiplying the previous by a common ratio r. So instead of repeated addition or subtraction, this will be repeated multiplication, all right, which technically I could also simulate repeated division if r happens to be a fraction that's less than 1 and bigger than 0 sort of thing, right? So, geometric sequence, it says, is a sequence in which each term after the first a sub 1 is the product of the preceding term in the common ratio r. The terms of the sequence can be represented as follows, where a sub 1 is non-zero and r is not equal to 1 or 0. So the first term would just be a sub 1. Second term, a sub 2, could be found by multiplying by r. Third term could be found by multiplying the first term by r squared, right? Because multiplying by another r, you would add the exponents. R times r is r squared. Multiplying by another r would be r squared times r, which is r cubed. You guys get the idea. Now, question in general, why would it be uninteresting if a sub 1 was 0? Yeah, the whole list would just be all zeros, and I wouldn't necessarily call that geometric. That would just be like 0. That'd be lame. Also, why would it not be interesting if r was equal to 1? Because, yeah, that could be like, it would just be the first term repeated forever. That's also not interesting. Or what if r was equal to 0? Not, it would be like some number, and then from then on it would be 0, 0, 0. I just wrote the number 3000 there for some reason. So this is kind of how I could describe that. So the common ratio, just like the common difference, you can find it using any two consecutive terms in the sequence, except instead of subtracting them, we're going to divide the latter by the former. So a sub n divided by a sub n minus 1. So it could be the first two terms, second divided by the first, or it could be like the fifth divided by the fourth. Whatever would give us the common ratio. So now that we know a little bit about this, let us do a little derive of a formula here. I love these little derivations. Derive. So, yeah, discovery, derive, describe, discovery, derivery. Formula. So let's see, I'm going to just kind of have a quick little list for us to analyze. So let's see, the first term, the formula to find the first term would just be whatever your first term was. The second term would be a sub 1 times r, right? The third term, we just wrote some of these down a moment ago, would be a sub 1 r squared. Now that's not a 3, that's a 1 there. A sub 4, the fourth term, would be a sub 1 times r cubed. So if this pattern was to continue, what would the nth term be?
A sub 1 r minus n minus 1.
R to the n minus 1th power, right? Because when this was 4, this was 3. When this was 3, this was 2. This was 2. This was 1. And when this was 1, you could technically have viewed this as r to the 0, which was equal to 1, having no effect on a sub 1 because multiply r to the 0 would be equal to 1, right? So, yeah, so it looks like we've just discovered our nth term of a geometric sequence formula. Wow, that was so exciting. So exciting. So here we go. I actually just took up a lot of real estate for that derive, but that's okay. Hopefully I don't regret that. So, the nth term of a geometric sequence. I like how I've titled it, and then the very first part of it is the title just repeated, non-capitalized besides the first letter. It's pretty good. Actually, you guys should probably just jump right down to writing the formula, really. Because you guys know what I mean by r, you know what I mean by a sub 1, right? And we also just wrote the formula down a moment ago. Water. Whew. I just installed a new Brita filter on my faucet. I was quite pleased. A little bit. Yeah, my old one. Oh, well, here's a anti-Brita story if you want me to balance it out so I can, equally qualify my statements. But yeah, my old one gained like a pinhole leak in the hull on the top, so whenever I'd turn the water on, like a near invisible stream of water would shoot like 4 feet into the air. And then like it would just be raining in my kitchen, like misting really. But it was pretty good. So Brita. So here we are. Ooh, I like this one. Find the a sub 8 term, or the 8th term. I guess I could have just said find a sub 8 in the geometric sequence. That's fine, though. If I've got -3, then 6, then -12, then ... forever. ... forever. What's it? What's the...
Did it say -12?
Yes.
Yeah. If 3 periods make an ellipse, what do 3 commas make?
Nobody uses
A Wi-Fi signal?
No, that's like parenthesis, almost.
Just be aggressively very small Wi-Fi signal. Just get a bad signal.
So let's label what I know, friends. Let's say that the first term, what's that? Okay, we're that good. Yep. What else do I know? Let's see. Do I know R? I could find R, though, dividing any two of the consecutive terms. So 6 divided by -3 is -2. And let's see. I know that N is equal to 8. And a sub 8 I'm looking for. Right, so I've labeled everything I know, and now let's just plug it in. So a sub 8 would equal -3 parentheses, -2 to the 8 minus 1th power. So that is equal to, remember exponents before multiplication here. 8 minus 1 is 7, -2 to the 7th. Is that going to be positive or negative? The -2 to the 7th part? Negative because it's an odd exponent. So it's an odd number of negatives being multiplied. 6 of them pair up and become positive, but you end up with that one -1 left over. It's like there was like an odd number of people at prom, and then the even number of them start dancing, and then there's one sad person in the corner.
It's okay.
No, Luke was dancing on a chair at one point. I saw that. What was your question?
Why is R so
Because I found the common ratio dividing any two of the consecutive terms. You also could have done -12 divided by 6. Luke is a great dancer, and I'm not just saying that because it's his birthday.
Oh, I'm turning red, guys.
I think he might have been the best dancer at all of prom.
Does Norway agree? Norway agrees.
Yeah, let's get an international consensus here. So, so notice that this was alternating in sign for the whole pattern because R was negative. Every other term is going to be positive or negative as a result. So that's kind of interesting, and we happen to land on a positive one. That's nice. But R, the common ratio, can also be a fraction, as you might see in some problems. I think I'm going to skip this example just because I feel like it. Just to, but R can be a fraction. You'll probably see some fraction ones on your homework as well. But let's talk about this one. I like this. Ooh. Oh, I don't know if I'll fit this over here. Ah, blast. I'm sorry for my language, friends. Example. Whoa. So write this down. How many terms are in... Oh, dear. It's pinwheeling. How many terms are in the geometric sequence? Right here. 36, 6, dot, 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 1/36. Oh man, guys, this is... Oh, this is real bad pinwheeling. I think there's less than 10.
Oh, 6.
What? Just leave their phone.
6.
This application is not responding, guys. We've got a hard crash here.
Wait, are we still recording?
Yeah, we are.
Wow.
Tell you what, this is going to be an amazing video.
Hashtag embarrassing.
Yeah, here we go. How about this?
6.
Here's the same problem. I'll just show you my little note version of it.
Trying to reconnect.
Yeah, I know.
Yikes.
Everything's just sad right now. So how many terms are in the geometric sequence? Well, this is the formula I'm looking for. I know the first term. I know the last term. I don't know what term it is, though. So n is the unknown to me. How could I have found r?
By dividing 6 and 36.
Yeah, 6 divided by 36 is how I would have found r, because those are the only two consecutive terms I knew about. So I would just then now go in and plug in everything I know. So 1/36 is equal to 36 times 1/6 to the n minus 1. And wait a minute, guys. I've got a variable in an exponent. That's going to be interesting.
Don't make that.
Now, why can't I multiply 36 times 1/6 here?
You have to do the exponent.
Yeah, because the exponent is kind of like tying this one all up. So I actually, in order to solve, I have to divide both sides by 36. What is this equal to? Dividing by 36 is the same as 1
How did you know that?
over... Well, actually, sadly, no.
What? No. Don't you do the reciprocal?
Yeah.
By another 1 over 36, or multiplied by another 1 over 36.
No.
So it's 1 over 36 squared.
Yeah, and then you equal to.
Oh.
We're the same kind of dumb, Christy.
Congratulations. So 1 over 1296 equals 1/6 to the n minus 1. Guys, do you have any suggestions for us as to how we could get n?
Dogs.
Logarithms can get variables out of the exponent. Excellent, excellent.
That's awful. You should have never said
Wait,
that.
stop.
So we'll log both sides, and then power property out the log.
No. Bad dog. Oh, God.
That actually says lug.
Does it?
And that one down there says boy.
Yeah, that definitely does. Yep,
Wow.
I like it.
Is that a bingo? Yeah, what is that?
I don't even know what that is anymore. But it does have my least favorite number. No, 1/6 I'm okay with. It's 5/6 is my least favorite number in the world.
But I missed the one.
I'm gonna care to elaborate.
Wait, that's
Why?
Man, thanks for hanging out, internet friends. I'm gonna be a trooper. This is the last time I'll ever record this probably in my life, so this is a special treat. A little behind the scenes, Mr. Waddy. That's right, I have Google Docs with my notes. So I pull the n minus 1 out front. I distribute the log of 1/6 to both of those, and then I move all of the non-n's away, and then I'll divide. And you end up getting n equals 5, which I'm sure was extremely apparent. Actually, I bet if I worked in base 6, if I used log base 6 on both sides, I could have actually made this problem a lot easier for us. But I used a calculator to figure it out myself, which is fine. Which is fine. So friendly friends, you can solve for any part of this formula for the nth term, right? Plugging in what you know, solving for what you don't, and in this case, we could even solve for n, which was in the exponent, using logarithms.
But why?
Why? Because maybe we wanted to know how long this list was.
Think of all the times you've had the first two numbers of the sequence in the last one, and you needed to know how many numbers.
Yeah, think about it. So, not unlike the class yesterday, Friday technically, we're also going to talk about geometric means. Let's see, this is still trying to reconnect, so I can't even edit this one. That's so sad. Which also, by the way, shout out to Google. They just made Google Drive so you could like edit your documents offline. I don't know if you guys heard that. Yeah, so like on the tablet, you can actually download Google Sheets and Google Docs. So you can be like working on it, and then you like walk out into the woods and you're typing your awesome like short story that's going to make $1 million. And you could like keep working on it. It's so great. So
Yeah. How does it
Oh, it saves onto your phone.
it would like resave it. Yeah, it would save it onto your device, and then it would resave it, sync it up to the internet later.
Yeah.
So, geometric means are the terms between any two non-consecutive terms of a geometric sequence. So, it's similar to arithmetic means, except this time it's a geometric sequence. So, find two geometric means between 48 and negative 750. So, I would set this up like this. Hello. I told DJ to come figure out a time. I don't know if Tuesday next week makes sense. It doesn't matter to me.
someday?
Yeah. Someday where, yeah. If you're not, as long as you're not doing other class meetings that day.
Well, I don't have to be involved, right?
No,
Oh.
no. I just figured you'd be a good person for him to talk to. Maybe. So, let's see. Oh, it's trying to reconnect again, guys. Wow, this is the best video ever.
Some devoted fan is gonna be like, wait, he doesn't actually just come up with this stuff off the top of his head.
I used
Maybe
to.
really mad.
I used to, actually. And actually, these questions that I'm writing down now, I wrote after looking at my screen grab from last year's lesson, even though I didn't record a video from last year's lesson. Oddly enough. So how could I find these two geometric means now that that's not working? Well, what do I know? Let's label the variables that I do know. I know a sub 1. I know a sub 4. Well, because I'm looking for two geometric means, so I do know that that's the fourth term in this list. And I also, because I know it's a sub 4, I also know what n is. N is equal to 4. So all I'm looking for is the value of, let's see, is it kind of connected? Here we go. So I know A1 is equal to 48. I know that A sub 4 is equal to negative 750. I know that N is equal to 4. And I'm looking for R, the common ratio. So I would just set that all up and figure it out. Let's see if I can really make this awesome. Let's insert an equation here. So let's see, what would that have looked like? That would have been negative 750 is equal to 48 times R is unknown to us. Actually, let me do it this way. Insert the little R to the 4th. So how would you solve this for R? Oh, 4 minus 1. Good save. You're saving me. It's so good because this video wasn't ruined beforehand. Yeah. So I would divide by 48 and then cubed root both sides, and I'd get the answer for R. And then I could just multiply each term after the first by that number and verify that it all works out. So negative 750 divided by 48. I don't think it's going to be that nice. Negative 750 divided by 48 is negative 15.625. Actually, that, ooh, interesting. And then cubed root that number, which Cubed root
Well, if you call this thing,
negative 2.5. Yeah. Wait a minute. Wow.
Yeah.
How did you suspect that Sam was going to call it?
because I don't know.
Like you just saw the math in his face, like, and it was on video. It was recorded. Like, just for all of our online viewers, Sam had no calculator in hand. He was just like doing this. It was, yeah, he knew the cubed root of that. That was pretty good. I liked it. No, he knew. Add in the comments. Start adding some, like, you know, favorite Sam quotes or something on the comments of this video. It'll be great. People will start a fan base for him. So once I know that it's negative 2.5, I could then multiply 48 by that and get the second term, and then multiply that term by negative 2.5 to get the third term. I won't walk through that. I'm sorry, it's trying to reconnect. Oh, discover you don't have to write down. So a geometric series, we've been talking about geometric sequences. That's a list of terms that are formed by repeated multiplication. A geometric series would be the sum of a portion of that list. All right, so it would be like add up the first 10 terms or 30 terms or whatever it is. So let's do a little discovery here, which you don't have to write down. So what I've got here is the sum of that list, right? First term, second term, third term, all the way to the n-1th term, okay? Or that is actually the nth term. That's exponent would be n-1 because that's what the formula is for the a sub n. If I multiply this all by r, okay, a sub 1 times r becomes a sub 1 r. A sub 1 r multiplied by r becomes a sub 1 r squared. A sub 1 r squared multiplied by r becomes a sub 1 r cubed, right? All of the exponents just increase by 1. So it becomes kind of like offset, right? You see that? And notice I offset it intentionally where these all kind of line up with each other. And I would then subtract the second row from the top row. So I get s sub n minus r s sub n. a1 minus 0 is a1. These ones cancel, 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 cancel. And then 0 minus a1 r to the n. Actually, that should be a minus sign, shouldn't it? Wow. Not only does this video have all sorts of technological errors within it, now it's got mathematical ones as well. Guys, I'm so glad I'm retiring. This is the worst video. Yes, I think there's about 1 billion of them. That'll just be devastating.
Wait, how many subscribers do you have?
Around 1 billion. So yeah, these are minus signs. And then I would factor out the s sub n and divide. Guys, that means the rest of this is, well, this part is wrong too, because it's a minus sign. But the good news is this is right.
Which one's a minus sign?
The top is a minus sign. Yeah, write down that formula with a minus sign there. And I can't even edit it, man. This is so terrible. It's the sum of a finite geometric series. We will talk about infinite geometric series later on.
Like later on in this video?
Not in this video, no. Don't worry. We'll talk about infinite lists. Yeah. And talking about class meetings and oh my goodness.
Yeah, there's no way.
I think I have to post this.
The top is a minus sign
Yeah.
instead of
You should
an
tell
addition
us
sign.
earlier.
This is perfect.
I should like
Just for a plus sign.
Oh.
Well, I wrote it before you.
I wrote it after.
let's see, the formula sheet that I gave you guys though, I think still had the minus sign. I'm pretty sure.
Oh, I got it. It does.
I'm writing out an example too.
Yeah, and this is the last example. Wow. What if, like, at the end of this terrible video is when I reveal my awesome Mr. Waddy secret?
That would be awesome.
But then, like, in the comments, people would just be like, skip to minute, like, 32:50, and then, like...
Delete them. Yeah, you can block comments.
Reveal it.
Or what if, like, you
You put it
alphabet...
in the title of this video.
You guys
Don't actually
see.
be like, Mr. Water reveals his next career.
Ooh.
Slash.
Make them watch this
Slash
awful
geometric
video.
sequence series.
Make everyone watch this awful video.
Yeah, you have to, like, synchronize every syllable I said on a geometric sequence where the first syllable I say at second 1, and then the syllable I say at second 5, and then the syllable I say at second 25, and, like, you have to, like, parse it all together to get, like, the
Have
code.
little pop-ups that say, stay tuned for Mr. Water's, like, thing at, like second, or, like,
Ooh, yeah.
minute 2 or whatever. And they go to minute 2 and be like, it's actually minute 4 because I miscalculated or whatever.
Ooh,
And
that'd
then
be so great.
and then all the way to the very end because they have stickers or like what?
So, if I want the sum of the first 10 terms of a list that's geometric, we've got, here's my list, 1, then 1.5, then 2.25. So, I know the first term. I was able to calculate R using the division of any two consecutive terms. So 1.5 divided by 1 or 2.25 divided by 1.5 also would have given me the same answer. And then I know that n is equal to 10. And for my formula, I'm trying to find the sum of the first 10 terms. Notice the nice thing about this formula. What didn't I need to know?
Lots of things.
I did not need to know the nth term. I don't need to know what the 10th term actually was. No, that's the common difference. There's the R is the common ratio on this one. So I don't need to know what the 10th term is to find the sum of a list in a geometric sequence. Okay? So I just need to know what the first term is, what R is, and then what number that term is.
So,
What's that?
why is that 1.5 not? Why is it raised to the 10th, not 10 minus 1?
Because in the formula it is raised to the nth power. If we look at the derivation, that was done wrong. Because I did the multiply by R, it increased the exponent by 1. So that's why it was just n. And then that would have been the minus sign there still. But yeah. So yeah, good question. Good question. So for the sum, it is not n minus 1. So then yeah, I just do all this out and then divide by negative 0.5. And I can find the sum of a list of geometric terms. Oh, I've got bus duty today. Best video
Wait, so those should
ever.
be positive?
No, these, well, a negative divided by a negative became positive.
Oh, right. Okay.
What if even with all of this terribleness, this is still the best way to learn this on the internet? Like no one else on the internet teaches it as good. I bet. No, I didn't say I was teaching English. My goodness. So, also just be super careful with your order of operations on this. Right? Exponentiate, multiply, then subtract. Do the subtractions with top bottom first. And then you just divide. And that's what those add up to. Now, in terms of sums of lists in geometrics, because you can have alternating signs, right? If R is negative, then every other term is negative. The sum of those lists can be particularly interesting as a result. But, yeah. So, I think we're good. Thanks for making it to the end, Internet friends. As a result, I will sing a song. What song should I sing?
No, that's not right.
Bailamos. That's the only part of that song I know.
I sing it.
Hmm. Yeah.
It's like a 2004.
Yeah, it does mean that we dance.
Really?
Did I spell lyrics right? I think I did. Here we go. All right. Oh yeah. This is. Let's see. I don't know the music, but here we go. Tonight we dance. I leave my life in your hands. We take the floor. Nothing is forbidden anymore. Don't let the world in outside. That doesn't make sense. Don't let a moment go by. Wait, are they inside or outside?
It's Spanish, okay?
Okay, all right. Yeah. That's of course that's what a French person would say. Nothing can stop us tonight. Bailamos. Wait a minute. Why is it a question mark? Are we dancing? Are we dancing right now? We dance. Let the rhythm take you over. Bailamos. Wow, this is amazing. Mr. Nickel, did you know the lyrics to Bailamos by any chance? Oh wow, this has crashed too.
I can honestly.
Enrique Iglesias.
Wow, I so cover Hispanic Latin American music.
Oh, okay. I figured you might know.
No,
How can I help you today?
You probably should ask his now.
Yeah.
Seeing as it is Cinco de Mayo, Felicito.
Yeah. That's why. Yeah. That's why we're looking this up, of course.
Which, of course, I'm slightly confused of really why is Cinco de Mayo like a big celebration?
It's like their revolution, right?
Huh?
It's their Independence Day.
Is it like some revolutionary?
No, they didn't
Sorry,
conquer.
Tristan.
The
One
French
There
raided
were 6,000
Mexico,
French
and Mexico defended.
pitchforks.
And overturned
Yeah.
them.
And, yeah.
Yeah. Take that, France.
Said Napoleon's forces home. Okay, well, if that's what it is, then now I understand.
Did you read that little handout?
Okay.
I was thinking Commissioner Tucker Boyd.
I'm in the
No.
Spanish.
Maybe next. I don't know.
Yeah.
He said something about having finished an exam. And I wasn't sure.
I don't have him. It's probably Mr. Wood's room.
Okay.
So guys, this has crashed as well. But
You can search another song.
take Hiro Amor Mio. Amor is a noun.
Yeah, it's love.
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 Yeah. Yeah.
That's, it means I want you my love.
I see that. Yeah. I like how he translates within his song.
Wait, no, he doesn't. That's just a translation.
Yeah, so
It's
it's
not
translated.
yours. You can make it happen. I'm so.
I think you don't think he sings that part?
I know that he does.
Let's listen to it.
Oh, you're probably right. So this lyrics website, which crashed on me by the way, I'm very disappointed in because I was singing these English parts of the lyrics that were supposed to be Spanish.
You can still sing it.
You're wrong. I play the piano. You don't.
So anyways, thanks for watching Internet Friends.
His brain is crashed.
I just want you to know, Internet Friends, that I won't let it go. There's something I think you should know. It's true.
That's next
Bye-bye.
Monday.